A very good day to our lecturer, T.S. Dr. Muhammad Hatta bin Jufri, and to all my fellow classmates. Today, here we are to present the assignment of power quality, which is titled as Power Quality Disturbances in the Malaysian Electrical Power System. And the subject code is BELK 4863. The subject name is Power Quality. And these are our teammates. So firstly, myself is YUSHMITHA, followed by AMMAR, followed by AIMAN, ELSON, and Neo. So these are the table of contents, which contains of 11 questions, and we have separated our works according to the questions. So firstly is question 1, will be presented by me. So I'll start my presentation. So there are many types of power quality disturbances, and I have listed some of them, which is voltage sag, voltage swell, interruptions, transients, harmonics, voltage imbalance, flicker, frequency variations, electrical noises, and overvoltage and undervoltage. Next is the challenges and mitigation in Malaysia, which is installing the power conditioners, surge protection devices, energy audits, distributed energy resources, and then the mitigation strategies. Power quality issue in Malaysia are deeply intertwined with its climatical conditions such as lightnings and floods, rapid industrialization, and evolving energy landscape. Mitigation strategies must account for these unique factors by focusing on upgrading grid infrastructure, especially in rural and flood-prone areas, improving lightning protection systems all across sectors, deploying advanced monitoring and mitigation technologies in industrial and renewable energy systems, raising awareness about PQ impacts, and solutions among businesses and policymakers. Question 2 is harmonics in power system. Firstly, the causes of harmonic distortions are non-linear loads, renewable energy system, industrial equipments, electronic devices, poor power factor correction, which is PFC equipment, infrastructure and distribution network design. And then the unique factors contributing to harmonics in Malaysia are the rapid urbanization and industrialization, renewable energy adoption, high penetration of lightning protection devices, hybrid grids in rural areas, and the seasonal and festive power demand. And there's also a case study in this question number 2, which is harmonic distortion in Malaysia semiconductor in industry, where a semiconductor plant in Penang experienced recurrent issues with harmonic distortion affecting the production efficiency and operational costs. The plant has noticed frequent equipment malfunctions, increased energy costs, and unexplained downtimes. Firstly, the identified problems are the increased total harmonic distortion, equipment failures, transformer overloading, and production losses. The root causes are the non-linear loads, inverter-driven solar PV system, resonance with power factor correction capacitors, and the grid-connected harmonics. The impacts of these operations are the increased operational cost, reduced productivity, risk of fire hazards, and regularity of non-compliances. The mitigation measures are install active harmonic filters, replace power factor correction capacitors with tune filter, upgrade transformer and neutral conductors, coordinate with TNB for grid quality, and employ training for power quality monitoring. Next, I will pass it to my another group member to present this. Thanks.
Okay, thank you. Next, I will continue the presentation. I will present the question number 3 about voltage imbalance and flicker. Voltage imbalance is unequal magnitude or phase angle in three-phase voltage, measured by the voltage unbalance factor. The main cause in Malaysia is by uneven single-phase load, faults distribution system, renewable energy, and industrial loads. Next. For voltage flicker, repetitive voltage fluctuation, often seen as a flicker slide, measured by short-term and long-term flicker in decade. The main cause in Malaysia is by industrial equipment, sudden load change, and by solar PV variability. The impact of the equipment and efficiency for residential, malfunctioning device, increased energy losses, and safety risk for flickering light. For industrial, motor overheating and failure. In production delay and disruption, high maintenance and energy costs. For case study, manufacturing plant in Johor. The problem is motor failures, fluctuating light, and product interruption. The cause is by unbalanced load on three-phase system, supply fluctuation from a nearby solar farm, aging transformer, and distribution line. So solution implement is by load redistribution for better phase balance, voltage regulator to stabilize supply, and infrastructure upgrades and preventive maintenance. The result is 85% reduction in motor failure, 30% improvement in production efficiency. Next, I will pass the presentation to next.
Thank you, Amma. Okay, so my turn. Okay, power quality standard and regulation. global standard. Power quality standards are essential for ensuring the reliability and the efficiency of electrical power system worldwide. Next, for standard in Malaysia, it's Suruhanjaya Tenaga play the currency role in regulating the power quality. Next, for global standard, it used the IEC 61000 series in the collection in international standard that focus on electromagnetic compatibility. First, International Electrotechnical Commission, IEC standard. First, general definition and concept. Second, environment specific standard. Third, limit for harmonic emission and voltage fluctuation. Fourth, testing and measurement technique. Fifth, installation and mitigation guideline. Next. For IEE standard, IEE standard 159/2014 focus on harmonic control and assume power quality. For 1159/2009 offer recommended practice for monitoring electric power quality. And last, 11500.3/2019, the transfer of the power quality data and accurate the data change. Next. For standard in Malaysia, it is the Commission enforced standard and guideline to issue the safety, reliability, and efficiency. First, electrical supply, SG 190, stability legal framework for electricity sector in Malaysia. Second, electricity supply. The law update adds a new rule for safety plan. It want to improve the overall electricity safety. And last, guideline on electricity safety management plan and program. The guideline explain how to keep the electricity safe and manage the power problem. Next. 4.2 Tenaga Nasional Berhad, TNB. The TNB power quality guideline. TNB give the road to fix the power problem like the voltage drop, harmonic, and suddenly change. Next, I will pass to my friend. Oh, sorry. For analysis of electricity for power quality regulation in Malaysia, effective of regulation. Suruhanjaya Tenaga. The law in Malaysia make sure electricity is the safety and reliability. Tenaga Nasional Berhad, TNB. TNB help the people understand the power problem and they give the solution. Next. Enforcement. First, monitoring and compliance. They are challenged in the monitoring and enforcing the complaints. Second, awareness and education. Enhanced education campaign and outreach program are necessary to bridge this gap. And last, technology advances. The technology advancement in electric and electronic equipment can outpace the existing regulation. And last, next. So I will pass to my friend.
Thank you very much. So I will continue for question 5, which is measuring power quality parameters. So what is measuring power quality parameters? It is essential for ensuring the efficient and safe operation of electrical systems. Power quality parameters indicate how well electrical power supply to equipment matches the ideal sinusoidal waveform at a constant frequency and voltage. Next. So the first point is list and describe the instrumentation used in PQ measurement. For example, power analyzer, harmonic meters in Malaysia facilities. So first of all is power quality analyzer. Power quality analyzer in Malaysia widely used by TNB and industry, measured by voltage, current, harmonics, power factor, sex, swells, and transients. They offer simultaneous measurement, real-time logging, historical data, and comply with IEC 61000-4-30 standards. Harmonic meter. Harmonic meter in Malaysia are used in facilities with non-linear loads, such as data centers and manufacturing plants to measure harmonic distortion in voltage and current expressed as total harmonic distortion, TSD. Next. Oscilloscopes. This device display waveform to detect transient and distortion and feature high resolution screens with portable of all bands top designs. Then multimeters, portable devices that are basic voltage that can measure voltage, current, frequency, and THC measurement are very common in Malaysia for quick, affordable on-site troubleshooting. And then a claim meter. These compact portable devices claim around conductors for non-invasive current measurement widely used in Malaysia for quick panel checks. Advanced model measure power and harmonic. Next. And for the second point is which parameters are critical for assessing PQ in Malaysia power system. So first critical is the voltage parameter. Voltage checks gives temporary reduction in voltage, often caused by faults of high inrush current. Voltage swells, temporary increase in voltage typically due to load drops of switching. Voltage interruption, complete loss of voltage lasting for short, momentary, or long duration. And then there's a harmonic. So harmonic, voltage harmonic refer to distortion in the voltage waveform caused by nonlinear loads like variable speed, variable drives, or LED lighting, while current harmonics are distort current waveforms due to equipment such as rectifier or inverter. With THD, including voltage THD, should typically not exceed 5% for most systems, and current THD, which varies based on load types, but should remain within acceptable range as per IEE 519. And then there's a power factor. So power factor the efficiency of power usage in system in reflect by its power factor. Where a low power factor is lower than 0.85 can result in higher energy losses, penalties from utility providers like TNB, and impact frequency stability. And then there's a transient. I'm sorry, power factor. It is indicate the efficiency of power usage in the system. Sudah. Next.
Okay, now we'll be presenting question number 6, which is monitoring and analyzing power quality data. Firstly, the key tools for power quality monitoring and analysis. Firstly, the power quality analyzer, digital fault recorders, smart meters, CADA systems, IoT-based power quality monitoring system. Materials techniques for power quality monitoring and analysis. Firstly, is time domain analysis, frequency domain analysis, trend analysis, statistical analysis. Then the challenges in Malaysia are high lightning activity, aging infrastructures, renewable energy integration, and cost controls. Next is monitoring how data-driven analysis predicts and prevents power quality issues. Firstly is a real-time monitoring analysis, where real-time data collecting through smart meters, power quality analyzers, and IoT-enabled sensors provides continuous visibility into power quality parameters like voltage, frequency, harmonics, and transients. Next is the historical data analysis, where the historical power quality data is analyzed to identify patterns, trends, and recurring issues. Followed by predictive analytics and machine learning, where the predictive models use algorithms to analyze data and forecast future power quality issues. Then the correlation analytics, where it is analyzing and correlations between different power quality parameters and external factors, and advanced algorithms identify deviations from normal power quality conditions. And finally is the load forecasting and optimization, where it analyzes of consumption patterns, helps forecast demand and manage load distribution. Next, I'll pass it to my team.
So for question 7, for quality mitigation techniques, various techniques are available to address power quality disturbance, with each offering distinct benefits and challenge. So the first one is harmonics filters. It is to reduce the harmonics distortion and ensuring the sensitive equipment remains protected. Next, the surge protectors is to shield the electrical systems from voltage surge caused by lightning strikes, power line crossovers, or switching operations in the grid. So the last is uninterruptible power supply, UPS. It provides backup power during outages and maintaining continuous operation of critical equipment. So these are the advantage and limitations. So for harmonics and harmonics filters, it advantage to effective at reducing the harmonics and customizable solutions. And the limitation is high initial investment and there's a power loss. Next, for surge protectors, it's easy and affordable and prevention of overvoltage. The limitation is limited in scope and wear out over time. Next is UPS. It is for the critical load protection and voltage stabilization. The limitation is limited runtime and maintenance costs. Next. So the application in Malaysia, many industrial sectors in Malaysia, particularly those with heavy use of BFD, employ harmonic filters to mitigate the damaging effects of harmonic distortions, thus ensuring reliable operations and extending the lifespan of machinery. For such protectors, it is widely used in both residential and commercial sectors, particularly in regions with high incidence of thunderstorms, to safeguard the electronic devices and equipment. So lastly, the UPS systems are commonly used in sectors that require uninterrupted power supply, such as hospitals and data centers, to ensure that operations continue smoothly even during the electrical interruptions. Next. So for case study, addressing the harmonic distortion in a manufacturing plant, the problem is a manufacturing plant in Malaysia face excessive harmonic distortion due to the use of variable frequency drives. This caused overheating in transformers and equipment malfunctions. The solution is the plant implemented a combination of passive and active harmonic filters. The passive filters were effective in addressing the lower order harmonics, while active filters were used to target higher order harmonics specific to the BFD. The outcome is the harmonic distortion was greatly reduced, resulting in fewer equipment failures and lower maintenance costs, and improve the overall operational efficiency. Next. For the question 8, the power quality and renewable energy systems, the integration of renewable energy sources such as solar and wind power introduce new challenge related to power quality. So for the impact of solar energy is harmonics. The solar inverters, which convert DC electricity to AC, can introduce harmonic distortion into the grid. Next is voltage fluctuations. It changes in solar generation due to the weather condition or time of day can cause voltage fluctuations that affect the stability of the grid. About wind energy, the harmonic distortion and reactive power. The wind turbines, especially those with older or poorly designed inverters, can cause harmonic distortion and contribute to reactive power imbalance. The frequency variation. The wind energy generation is highly dependent on wind speed, which can lead to frequency fluctuation and cause power quality disturbance. Next. The solution to minimize the PQ issues from renewable energy sources. The first is advanced inverter technology. Modern inverters are equipped with features like voltage regulation, reactive power compensation, and harmonic filtering, which help mitigate the PQ issues. Second, energy storage systems. Battery storage can help smooth out the intermittent nature of renewable energy by storing excess power during the peak generation periods and releasing it when generation drops. Third, grid modernization. Upgrading the grid with dynamic voltage controllers, power factor correction device, and real-time monitoring systems can help manage fluctuations caused by renewable energy sources and improve overall grid stability. So the last one is demand side management, DSM, is by adjusting the industrial energy usage to times when renewable energy generation is higher. DSM can help the balance supply and demand and reducing the PQ disturbance. Next. So for case study, managing solar PV induced the voltage fluctuations. The problem is a residential area in Malaysia with numerous rooftop solar installations experience voltage fluctuations, especially during the cloudy days when solar power output drops suddenly. The solution is to address the issue. The local grid operator installed inverters with voltage regulations capabilities and implemented a battery storage systems to store excess solar energy during sunny periods and supply power during cloudy conditions. The outcome is these measures stabilize the voltage levels, reducing PQ disturbance and ensuring a consistent and reliable power supply to the community. Next, I pass to the next member.
Okay, I will continue. Question number 9. Power quality in industrial environment. The critical factor impacting operations efficiency, reliability, and safety for Malaysian's industry sector. Ensuring stable and high quality power is essential due to the increasing adoption of automation, precision manufacturing, and the integration of renewable energy source. Next. Challenge and requirement of maintaining power quality in Malaysia industry sector. The challenge is voltage fluctuation, voltage imbalance, harmonic distortion, frequency deviation, and impact of renewable energy. The requirement of maintenance power quality is compliance with standard, robust grid infrastructure, monitoring system, and energy management. Next. Effective mitigation method for Malaysia manufacturing environment. First, harmonic mitigation. The method is by install passive active harmonic filter. Use 12 pulse or higher order rectifier. The effectiveness is reduce transformer heating and damage to sensitive equipment. For voltage regulation, method by deploy automatic voltage regulator. Use voltage stabilizer or tap changing transformer. The effectiveness is prevent operation delay and component damage. Next. For load balancing, method by distribute single phase load, use phase balancing transformer. The effectiveness is improve motor efficiency and prevent overheating. For power factor correction, method by install capacitor bank or synchronous condenser, use active power factor correction device. The effectiveness is lowest energy cost and avoid utility penalties. For power quality monitoring and early detection, method by install continuous monitoring system, use SCADA system for remote management. Effectiveness is enable proactive maintenance and avoid downtime. For renewable energy integration, method by use hybrid inverter with power quality optimization. Deploy battery energy storage system. The effectiveness is stabilize supply during renewable energy fluctuation. For the last one, surge protection method by install surge protection device at critical point. The effectiveness is shield equipment from lightning and voltage surge. That's all from me, and I will pass the presentation to Susan.
Thank you, AMMAR. So economic impact on business, production loss, voltage swell and interruption can hurt the production line, leading to substantial financial losses. Next, downtime costs. Unscheduled downtime due to power quality issue can be extremely cost. And last, operational inefficiency. Poor power quality can lead to inefficiency in operation. Next, calculate the potential loss in economic impact. First, to get the total economic loss, first equipment damage and fair loss from equipment damage, replacement cost plus repair cost plus lost production value. Second, downtime cost. Loss from downtime is equal daily production loss and duration of downtime. For mitigation cost, for voltage regulation, total economic loss is the total loss downtime, loss from downtime, plus repair cost and mitigation cost. Next. So I will give to pass my friend.
So for the last question, which is future trends and emerging technologies in power quality. So power quality is vital for reliable and efficient electricity with more renewable smart devices and decentralized grids. New technologies are tackling challenge and improving PQ. Next. So investigating emerging technologies in managing power quality. First of all is Internet of Things, IoT in PQ management. So IoT enable power quality systems offer real-time monitoring, predictive analytic, remote control, and cost-effective solutions for renewables and EV integration. Then artificial intelligence, AI in PQ management is AI in power quality supports fault detection, predictive maintenance, grid optimization, and energy management through techniques like deep learning, reinforcement learning, and NLP. Next. Integration of IoT and AI in PQ. So IoT and AI provide real-time insights, automate power adjustment, and use edge computing for quick responses. Smart grids optimize voltage and prevent downtime. while challenges like data overload, cybersecurity, and interoperability are managed with encryption and standard protocols. So to conclude, the IoT and AI improve power quality by enabling real-time automated solutions, supporting decentralization, renewable energy, and grid reliability, paving the way for smarter, more resilient power system. And the last point is how can Malaysia leverage these technologies to improve PQ? So Malaysia energy sector is shifting toward renewables, urbanization, and smart grids under the energy transition plan. So IoT and AI are key to tackling power quality challenge and improving grid reliability. So first is real-time PQ monitoring and diagnostic. Malaysia power quality issues stem from renewables, industrial demand, and aging grids. While monitoring is mostly urban, IoT sensor can expand coverage to rural areas, and AI can detect faults and enable proactive maintenance. Second is integration of renewable energy sources, RES. Malaysia aims for 31% renewable energy by 2025 and 40% by 2035. IoT sensors monitor renewable output and grid injection, while AI forecasts demand and generating optimizing inverter to stabilize voltage and reduce harmonics. Next, the advancing smart grids are microgrids. So Malaysia's smart grids work alongside centralized system. IoT enable microgrid communication for load balancing and V2G integration, while AI improve operation with voltage control, power support, and fault detection. So those who don't know what is V2G is vehicle to grid. And the last one is industrial power quality management. Malaysian industries face power quality issues from nonlinear loads and harmonic distortion. IoT sensors can monitor PQ and control harmonic filters, while AI optimize energy use, improve PQ, and enable predictive maintenance to prevent equipment failures. So then that's all from us. Thank you so much.